Right, let's try another couple of examples for normal distribution. Let's say a student makes this trip 180 times in a year. How many times would you expect it to take the student longer than 50 minutes? Well, it takes the student 50 minutes or more, 0.48 of the time. We worked that out in part A. Now, they're doing the trip 180 times, so 0.048 times 180 will tell you how many times you'd expect them to be late. Comes out as 8.6, so roughly 8 or 9. So what have we done there? To get the expected number, we've done the probability of that thing happening multiplied by the number of times it happens. That's how you get the expected number. Now, one other type of problem we haven't talked about is inverse normal. What if you know the probability and you're trying to find out the value on the normal distribution curve? A student is late to school 2% of the time. What time are they leaving if they're late that amount of time? So it's like we know that the trip takes too long 2% of the time, or 0.02. Okay? So we need to figure out what is this value here for that to happen. Now, one thing that's unusual about inverse normal is it only does to the left of the graph. So we have to convert that 0.02 to a value on the left. The whole curve adds up to 1, so the blue bit is 1 minus 0.02, which is 0.98. So now we know the blue area is 0.98, we just need to find the value down here. So we're going to do the opposite of normal CDF, which is called inverse normal, inv norm. And you press second distribution, same button that we've been pressing all along, and it should be the third one down. Enter the probability of the value to the left, enter the mean, enter the standard deviation, and you should get 51.1. So that means the person's late if it takes them 51.1 minutes. So school starts at 8:30, so if they left 51 minutes before that, which would be 7:39, they would be late. So if you know a probability and you want to work out the x value, you use inverse normal.